Okay, so we're going to find the area of an irregular figure. And what an irregular figure is a shape like this on the right-hand side. This is something that we don't have the equation to find the area of. You know, we do have the equation for things like rectangles, squares, triangles, circles, but when we get a shape like this, we don't have a special equation for this, so we're going to have to use a different kind of strategy. And the strategy that we're going to use here is we're going to split it up into simpler shapes that we do know the area equation for, and that's going to allow us to add up those pieces and find the area of the big shape. So if you take a look at this, we have to figure out some kind of strategy to turn this into shapes that we know. So one thing that I see right here is if I were to draw a line straight across right here, I've taken this irregular shape and I've turned it into two rectangles, and I know how to find the area of rectangles. So I'm going to be able to use the area of a rectangle formula to figure out what is the area of this whole shape. I'll figure out the area of this top rectangle. I'm going to figure out the area of this bottom rectangle. When I add those expressions together, that represents the area of this irregular shape. Okay? So if I'm taking a look at the top one, let's find the area of the top one, which I'll just write A top to represent that. Okay? Remember, the area of a rectangle is just the length, which for us here is 4x, and the width, which for us is negative 4x plus 5. And I'm going to write the area. So I'm going to say the area of this is negative 4x times negative 4x plus 5. Okay, this is how we would write length times width. And this is something that we know how to do. We learned about the distributive property. We can say, let's multiply negative 4 times negative 4. Well, that gives me 16. And x times x gives me x squared. And I can do the same thing and multiply this in, and say negative 4 times 5 is negative 20, and and we also have to bring the x along with the negative 4, so we're going to have a negative 20x. So I'm going to say this expression, 16x squared minus 20x, which I'm going to write in the box, represents the area of just the top portion of this irregular shape. Okay? For the bottom one, we have a little bit of a problem. If I asked you what the length of this was, I don't have an expression that represents that. I only know that this little piece right here is negative 3x. I don't have something that represents the entire length. Right? But what we do know is that in rectangles, whatever the length of the top is also the length of the bottom. So I can move this minus 4x plus 5 down into this space, and I can say that if I add together this little section plus the little section for the negative 3x, that together they will make up the length of this bottom rectangle. So just off to the side here, I'm going to do a quick calculation. I'm going to say we need to do negative 4x plus 5, and we need to add to that little chunk negative 3x, and those two together will make up that length at the top that I need. Well, it looks like this equals negative 7x plus 5. Okay? So I want to point out something now that these are side by side. You notice in this example when I multiplied, the exponent changed in each of these. Instead of being 1 each, I have 2 total. In this example, I added together a negative 4x and a negative 3x, and I did not change my exponent. Okay, and that's a big difference that you need to make. When you're multiplying, exponent changes. When you're adding, it does not. Okay? So getting back to the problem, I'm going to say this entire big line down here we can represent with this expression negative 7x plus 5. Okay? So if I'm going to find the area of the bottom section, which I'll call A bottom, okay, we're going to multiply together this negative 3x width, which I'm going to write the monomial first. That's pretty standard. And I'm going to multiply that with negative 7x plus 5. Okay, so again, I have a distributive property that I'm going to need to do. And so again, distribute negative 3x times negative 7x. Well, that's 21x squared. Negative 3x times 5 is negative 15x. Okay, so I would say that the inside space here, which we're going to clear out some of these pieces to make it a little bit easier to read. Okay, I'm going to say that this bottom rectangle's area is this expression here, length times width. So I'm going to say 21x squared minus 15x. Okay. So to find the area of this entire big irregular shape, I'm going to add together the area of the two rectangles. So I'm going to come down here and give myself a little bit of space, and we are going to say 16 x squared minus 20x plus, and usually we'll put polynomials in parentheses, plus 21x squared minus 15x. And remember, when we're adding together polynomials, we're just going to combine like terms. So 16x squared plus 21x squared, well, that looks like 37x squared. Negative 20x plus negative 15x, well, that looks like negative 35x. So I'm going to say the final answer to this problem, 37x squared minus 35x, represents the area of the original picture at shaded region because I added together the two rectangles that I created.